Well, hello class. This is Dr. F. We're going to begin our semester, the first chapter, introductory chapter for general chemistry. And we might as well begin, as the King of Hearts said, we begin at the beginning and go till we come to the end, and then we stop. Alice in Wonderland. Chemistry is considered the central science. It's a study of matter and energy and their interconversions. Now, I've highlighted these important words: study, matter, and energy. Chemistry is considered a central science because it impacts on many other branches of science: agriculture, medicine, pharmaceuticals, food, textiles, construction, petroleum products, fuel, cosmetics, etc. When I say study, I mean it is a scientific study. It is a science. And it employs largely the methods of science, what we call the scientific method. And I show here some key terms that you need to be familiar with. Empiricism. Empiricism means observations using our senses, rather than acquiring knowledge from inspiration or from just basic logic or from other learned individuals. Chemistry is largely an experimental science which is based on observations. Now, these observations attempt to understand some natural phenomena. And when we observe a natural phenomena, we would like to try to explain it. We do this by generating a hypothesis, which can be called an educated guess of what might be the explanation for something, how something may operate. And we then attempt to experimentally test this hypothesis. Now, most often, we will wind up having to revise our hypothesis or make additional measurements to refine as we go. But if we continue to study something, at some point, we might generate a law, that is what I sometimes call a pithy statement, oftentimes a mathematical statement, such as F equals ma or PV equals nRT, or the first law of thermodynamics, something that can be stated very briefly that describes phenomena. And if our hypothesis withstands a number of challenges, a number of experimental observations, and can explain a very broad range of observations, it might at some point be elevated to the level of a theory, such as a theory of gravity. I usually say that the word theory, capital T for theory, means grand explanation. At the bottom right, I show sort of a relationship between some of these terms. At the bottom, we have observations, which we make in our daily lives, or perhaps we make as a part of the scientific process. And the right path shows what is called inductive logic, or inductivism, in which we make observations, generate hypotheses, test these hypotheses experimentally, oftentimes revise these hypotheses in an attempt to develop theories, explanations, laws. To the left is shown deductive logic. That is, once we have a theory or laws, we can use these to predict. So deductive logic means predicting behavior in new situations. So we said that chemistry is a study of matter and energy in their interconversion. So what is matter? Well, matter, it's stuff. We can consider pure substances and mixtures. A pure substance would be the elements, those members of the periodic table, which we'll spend a lot of time talking about: hydrogen and carbon and iron and calcium and potassium, etc. Or compounds made by bonding together elements in various combinations, such as H2O, C6H12, O6, sodium chloride, NaCl, by either ionic or covalent bonding. Or we can have mixtures. Mixtures can be either homogeneous or heterogeneous. Homogeneous mixtures are what we call solutions. A good example would be Coca-Cola. And a solution is one in which, if you have a container, such as a bottle of Coca-Cola, the top half and the bottom half essentially are the same. Whereas a heterogeneous mixture is something like a suspension, something like paint or mud or oil and vinegar dressing, where the components can be fairly easily separated from one another, oftentimes by gravity or filtering. So homogeneous or heterogeneous mixtures. We can also describe matter in terms of its properties, its physical properties, such as its color, its density, its physical state, which we'll mention in a second, or its chemical properties. Chemical properties meaning how it reacts with something else. Now, for the physical properties in particular, we can consider these to be either extensive or intensive. An extensive physical property is one where size matters. That would be, for example, mass or volume. Size matters. Whereas we can also have intensive physical properties such as melting point or temperature or density. For example, you can have a glacier of ice, water, or you can have an ice cube, and both will have the same melting temperature or the same density. So either extensive parameters which depend upon the amount, or intensive properties which do not depend upon the size of the sample. Let's talk about the phases of matter. Usually we'll be talking about three phases: solid, liquids, and gases. Solids are those condensed phases of matter. Well, actually solids and liquids are considered condensed phases of matter where the atoms or the molecules are very close to one another and sort of touching each other. In a solid, the atoms or the molecules will be arranged in a regular pattern, as we will see near the end of the semester. A solid holds its shape when placed in a larger container, and the solid occupies a fixed volume. So we sort of know what a solid is when we see it. The liquid phase is also a condensed phase of matter, but it is different from a solid in that it doesn't maintain its shape. That is, it will fill the bottom, under the influence of gravity, will fill the bottom of a container. A gas, in contrast, will expand to completely fill a container in which it is placed. A gas is also, among the three phases, the most compressible. We can change its volume by applying pressure. Now there's another phase of matter which we'll talk about maybe briefly, something called a plasma. It is a phase of matter in which the electrons and the protons and the neutrons are actually not linked together to form atoms. It's what we have in the sun and in neon signs. We won't spend very much of our time on the sun or in the neon signs, and so we will be talking about the regular phases of matter that exist on planet Earth. Now, study of matter and energy. So what is energy? Now, we will discuss energy in several contexts, including energy changes associated with chemical reactions or phase changes in the phase state from solids to liquids to gases. Energy of attraction or repulsion between charges and between molecules. We'll talk about the stickum between molecules that results in some molecules being more solid or liquid-like, more condensed, whereas other molecules do not interact with each other and remain a gas. We'll also talk about the energy that binds together subatomic particles. We'll discuss the laws of thermodynamics, the first and second law in particular. We will use the terms endothermic and exothermic. We'll use the terms kinetic and potential energy. We'll talk about the relationship between kinetic energy and heat and entropy and disorder. We will actually put a lot of emphasis on energy in our discussion of chemistry. Now, to keep these lectures from going on too long, I want to pause at this point and then create a second video lecture for this introductory chapter. So next, go to the second video for this introductory chapter. See you in a minute.